For this next question, we want to determine the inverse of this function. Hopefully we're comfortable with fractions. Then we're going to graph the function and its inverse and state the domain and range of each. Well, we start with a statement of what the function is, and we let that be y. We then want to switch x and y, solve for y. This is going to involve either partial factoring or completing the square or an alternate method. So here we are. We have the partial factoring method. We have an axis of symmetry at -3/8. We plug that value in for y. We get -67/32. So in vertex form, this is our function's equation. If we chose the method of completing the square, we could factor out 2/3, and then we would get this statement here by taking half of 3/4 and squaring it. Distributing the 2/3 to the last term would give us this expression. So now what we're going to do is switch the values of x and y. We have the same expression on both sides. So what we're going to do is switch the position of x and y. Then we're going to solve for y. We begin by adding 67/32 to both sides, dividing both sides by 2/3, which means multiplying by 3/2. We're then going to take the positive and negative square root of both sides, subtract 3/8 from both sides, and then restate our expression for y as f inverse of x. Okay. Now what we're going to do next is graph the curve. Well, we begin by graphing the original function, the upwards opening parabola, and it has a vertex of -3/8, comma -67/32. -3/8 is a little closer to 0 than -1/2, and -67/32 is a little farther from 0 than -2 is. So we get that blue parabola. What we can then do is graph the inverse by thinking of it as a reflection of the blue curve in the line y equals x. And it's very useful to have the blue curve for that purpose. However, we don't need it. We could use our transformation work. This was our expression for the inverse. Well, we could factor out 3/2, our k value, inside the argument there. And we would have 3/2 bracket x plus 67/32 inside the argument. And that would mean that our k value is 3/2, our d value is -67/32, and our c value is -3/8. And then we had two different curves, one with an a value of 1 and one with an a value of -1. And if we were to graph those two curves using our transformation approach, we would get the upper green curve and the lower green curve, and they would come together and look like one sideways opening parabola. We then want to determine the domain and range of the original function and the domain and range of the inverse. Well, looking at the blue curve, we see the domain is the set of all x's that are elements of the reals, and the range is all y greater than or equal to -67/32. Looking at the green curve now, we see that the domain is the set of all x's greater than or equal to -67/32, and the range is all y values that are elements of the reals. And we see, once again, that the domain of the original corresponds precisely with the range of the inverse, and the range of the original function corresponds precisely with the domain of the inverse.